This section is for those of you who are new to databases and database terminology. Here, I'll give you a quick tour of a relational database management system, or RDBMS, and the objects we'll be working with in case these might be unfamiliar to you. At the highest level, data is organised into a schema. This is used to group related database objects together. A schema represents a logical grouping or namespace for database objects such as tables, views, and procedures. You might remember when we set up our development connection in SQL Workbench, in the install video, we could have picked a default schema, but we left it blank. In some database systems, like Postgres and Oracle, the term schema is used to represent the namespace within a database where objects are organised. These systems can have multiple schemas within a single database. In other database systems, like MySQL, the term schema is often used interchangeably with database. In MySQL, you typically create databases and refer to them as such, but the SQL Workbench refers to them as schemas. I'll be covering the SQL Workbench user interface shortly, but just enough to get you familiar with it to debug the Java results we get. Within a schema or database, data will next be organised into additional database objects. The most common of these is the table. A table is a lot like a spreadsheet, so you have the concept of columns, which are attribute data you'll be storing. A row is a record in the table. Usually a row is indexed in some way, which allows fast access to that record. A record will often have one column that represents the primary key in the index. But tables can have many indices, and an index can be made up of more than one column. For example, if you had a student database, you might have a primary key on a student ID and a secondary key on last name and first name. An index is just another database object which contains information about the table it's indexing, a key value with a locator to the record. You remember how we used indexes in binary files. This is the same concept here. A view is really a stored query or a special type of stored SQL statement that can be used by clients, just like a table. This simplifies queries for the clients and hides implementation details of the tables. A user is also just a database object and comes with a set of privileges which control and limit what they can see and modify. Again, this is all super high level. You don't really need to be an expert in how databases work to access and take advantage of using one. Like any software, databases also have a language you need to learn to use to work with that software. In databases, the language lets us create objects, populate them with information, create relationships, and query data. This language is called a structured query language, or SQL, pronounced either SQL or SQL. The pronunciation that you choose is a matter of personal preference. I like SQL, but don't be surprised to hear many developers using SQL interchangeably with SQL. For relational databases, the language has become standardized with ANSI SQL, although each database may still retain some of its own unique clauses or commands. SQL is divided into two categories, Data Definition Language or DDL, and Data Manipulation Language or DML, which serve two very distinct purposes. The Data Definition Language is used to define, create, manage, and modify the database objects. DDL statements don't manipulate the data in the object, instead they manipulate data structures that store and organize the data. Some of the most common DDL statements are shown on this table. These are create, alter, drop, truncate, and rename. It's very common for database objects to be managed by a DBA or database administrator. I'll be covering a couple of simple DDL statements in some of the examples ahead, but for the most part, we'll be focusing on DML. The Data Manipulation Language or DML is used to interact with and manipulate the data stored within the database objects or artifacts. DML statements perform operations like inserting, updating, retrieving, and deleting data in the database. Some of the most common DML statements are shown on this table. These commands are often represented with another acronym you might be familiar with. This acronym is CRUD and it stands for Create. This operation involves creating new records or entries in a database. This is equal to an insert command. Read the read operation involves retrieving or querying data from a database. This is equal to a select command. Update. Updating refers to modifying existing data in a database. This is equal to an update command. Delete. The delete operation involves removing records or data from a database. This is equal to a delete command. CRUD represents the fundamental operations for managing data in a database system. Later, we'll cover different Java frameworks that all aim to simplify database interactions, making it easier to perform CRUD operations in your Java projects. So what makes MySQL and many of the other large database management systems like Oracle, SQL Server, and Postgres relational? Unlike a simple spreadsheet, data stored in an RDBMS can be stored in many different tables. The tables can be associated with one another through different kinds of relationships. The first relationship, one-to-one, is not as common as the other two. There are specific use cases where this makes sense, like storing large binary objects, images for example, in their own table. Another use case might be to separate out sensitive data, like salaries, from general data about an employee. A one-to-many relationship is much more common and would be cases like an order table with a relationship to its order line item table. A many-to-many relationship is sometimes called a cross-reference. Imagine a table of students and a table of courses. A course will have many students, and a student may take many courses. This is a many-to-many relationship. Designing a relational database is a special-note skill and usually ends up in a delicate balance between theory and performance concerns. I'm not going to cover this except to introduce you to the term normalization. Database normalization is the process of organizing data in a database mainly to reduce data redundancy and improve data integrity. It's a design process which involves breaking down a large table into smaller related tables and defining relationships between them. This process is guided by a set of rules, often called normal forms. The goal of each of these forms is to progressively eliminate redundancy, meaning a data attribute should be represented in only one table as well as dependency issues. Once the design process is complete, you'll have a schema full of tables with implicit or explicit relationships. Having data in these separate silos, where no data is repeated, is great for maintenance and storage, but it complicates data retrieval. So how do you get information out of these related tables without writing many multiple queries? You do this with something called a join. A join is a SQL clause that combines rows from two or more tables based on a common field. Joins are used to create more complex queries and to retrieve data from multiple related tables simultaneously. An inner join is one of the most common kinds of joins. You'd use this kind of join to get an order and its associated line items. This would return all the order data and each line item's columns as well on each record returned. If there are no order detail line items, an order wouldn't get returned. There has to be data in both tables, in other words. The left and right joins, sometimes called outer joins, return the full set of records described in the one table, either on the left or right in the clause, and any matching records found in the other. This means data doesn't have to be joined in both tables for records to get returned. A full join is similar to an outer join, except the records from both tables is returned, joined where there is a match. A cross join is also known as a Cartesian join, which is usually something to be avoided, except in very specific use cases. This returns all possible combinations of rows from both tables, which can blow up very quickly to be a huge amount of records. Don't worry if this doesn't make sense right now. I'll be covering some examples over the course of this section, which will help you understand at least the basics of some of these joins. Okay, so that's databases in 10 minutes. Now, let's start working with one. I'll see you in the next video.